Okay, so this is question 5. The diagram shows the apparatus that a student used to investigate the heating effect of different wavelengths of light. So the white light is coming in here. It is individually refracting. Altogether that's called dispersion. And then you can see the different wavelengths of red, green and violet here. So the process that's happening in X is actually going to be refraction. It's not dispersion, that's kind of the whole effect of what you're seeing. So the wavelengths are dispersed because of their different refractions. The student with a thermometer outside of the light spectrum, why would that be? Well, that's simply a control. Simply a control. Right, moving on. Right, so the table gives the position and reading of each thermometer 10 minutes after the investigation started. Okay. That's too much. There we go. Now, what should the student conclude from the data in the table? Well, if you look down here, you can see 2 marks, so you definitely should say 2 things. What can I notice here? Well, certainly the temperature of the red light went up the most. And if you look, the different colours allow the temperature to go up by different amounts. So I think I would say things like, for 1 mark, you could say different coloured light produced different temperatures. So that would get you 1 mark, but because it's 2 marks, you've got to say 2 things. So I'd say red light made the greatest change, the greatest increase. I suppose you could also note that outside the spectrum there was no change at all. 5b. A similar investigation completed in 1800 by the scientists of William Herschel led to the discovery of infrared radiation. Suggest how the student could show that the spectrum produced by the glass prism has an infrared region. Well, I think the only thing you can do really, if I go back to the diagram, here somewhere, I'll just get rid of that. If I go back to the diagram and show you this, well, really, if you were going to find any infrared at all, then you're going to find it just above the red light. So you'd probably find the infrared around here somewhere. So it would make sense to put another thermometer in that region. So if we go down and say as much as that, down at 5b here, how many marks is it? 2. Right, so let's try and think of something sensible to say here. So I think I'd say something along the lines of use another thermometer in the area above the red light. And then I'd say if the temperature goes up, this is because of infrared. Okay, right. I think there's one last bit to this question over here. Let's go down to the last bit. Right, only two more bits. Okay. So a calculation. Calculate the wavelength of infrared radiation that a person emits. Okay, well there, let's have a look here. Their frequency is that, and we've got the speed of light of infrared radiation is that. The equation would be wave speed equals frequency times wavelength. So if I put that in, now look, I'm emuing. Those of you I teach know exactly what I mean by that. Equation, maths, then the unit. So 3.2 times 10 to the 13 multiplied by 3.0 times 10 to the 8 meters per second. And all we need is a calculator now. Hang on, I have one here. And if I type that in, so 3.2 times 10 to the 13 multiplied by 3 times 10 to the 8 gives me an answer of 9.6, so if I write that in there, 9.6 times 10 to the minus 20, oh sorry, not minus, that's a mistake, meters. Okay, so that's a very, very long wavelength. Oops, hang on, your science teacher has made a crashing error here. Right, look what I've done wrong. They actually ask me calculate the wavelength, so I need to change the equation around. Whoops. Okay, so the speed is 3 times 10 to the 8 divided by the frequency of 3.2 times 10 to the 13. Right, that looks better. Let's try that. Okay, now I'm going to give the answer in standard form as well. It's 9.4 times 10 to the minus 6 meters. That's actually 9.4 micrometers. You could write it like that if you wanted to. And moving on, 5D. Thermal imaging cameras work better at night than during the day. Explain why. Okay, now you want to try and explain this in terms of heat, not light. So don't put anything about the fact that it's less light during the night. That's not going to be the answer. So at night the surroundings are cooler. And so that means and give off less infrared. Now that would get me 1 mark, and then for 2 marks say, so this is all about criminals, isn't it? Yeah. So the criminal shows up against the background. Now hopefully that should be 10 marks. I think so anyway.